Good day and welcome to the series on linear equations. Now, whenever I do an episode 1 of a new series, a new topic, I like to go right back to basics, especially for people who are just starting off on that topic, so that they can learn how to recognize when an example is coming from that topic and just to know more about it before they actually venture into it properly. So we get different types of equations. As I've said, we're going to do linear equations now. So if you were presented with an equation, and this is definitely an equation because it has an equal sign, then you need to look at the types of terms that are in the equation. And let's just recap a little bit of the vocabulary that we've learned. So this is an equation, not an expression, because it has an equal sign. It has 1, 2, 3, 4, 5 terms because we know the terms are separated from each other by plus signs, minus signs, and equal signs. And we would be able to solve this equation, and in episode 2 probably we are going to do similar things to this. But for now, all I want to do is to see that you can identify that this is a linear equation and not any other kind of equation. So we look at the variable, and we see the x variable occurring 3 times within the equation. And if you look at each of them, they are all simply x, which means x to the power of 1. None of them is an x squared. So if you have an equation like that where it's all of the x's are x to the power of 1, then it is a linear equation, which means that we're only going to get one answer for x. Other types of equations can give us more than one answer for x. So we're not going to solve this one. We're going to look at different ways of solving equations. So there is a method for solving equations which is called solving equations by inspection. So if we're solving an equation by inspection, we're actually working the answer out in our head because the equation is simple enough that we can simply look at it, do a little bit of calculations mentally, and then work it out. So if we have 8 plus x is equal to 19. Now remember, an x is standing for any number. And when we're trying to solve an equation, we're trying to find out what the value of x would be to make the equation true. And we also need to remember with an equation, we've got the equal sign, and then there's some things on the left-hand side of the equal sign. So all through this series, I'm going to be speaking a lot about left-hand side and right-hand side. So it's very important that at this stage you understand what I'm speaking about. So look at your equal sign. Everything to the left of that equal sign is called the left-hand side of the equation, and everything to the right-hand side of the equal sign is called the right-hand side. So if we look at this particular equation, the right-hand side is simply a number, a constant. So it has a specific value of 19, whereas the left-hand side has got a binomial. It's got 2 terms, and so we need to work out basically 8 plus what will give me 19. So anybody can really work that out in their head. So once we've done that, we're simply going to write x is equal to, and then 8 plus x to give us 19 is going to have to be 8 plus 11. So the value of 11 for x will make the statement true because the left-hand side will then become 8 plus 11, which is 19, and the right-hand side is 19, so we've made the statement true. Let's look at a situation like this. If we had 5x equals 35. So remembering that 5x means 5 times x, what value of x would make it true so that 5 times something could give me 35? We know our tables, so we know that 5 times 7 would give us 35, and immediately we've been able to find the value of x in our head by inspection. We could also get x over 9 equals 5. So remember that that line in a fraction means divided by. So we're saying some number divided by 9 will give me 5. Well, what number divided by 9 is going to give me 5? The only thing that would work would be x equal to 45. And again, if we go back and look at the left-hand side, now that we've put our answer number into the place of x, 45 divided by 9 is 5, and the other side is also 5. So it's like balancing it out. We've got to get the left-hand side balanced with the right-hand side. So what we're going to do for the rest of this episode is we're going to look at solving an equation using inverse operations. And for today, for this episode, we're only going to use the inverse operations of plus and minus. In the next episode, we'll go on to where we also need to use times and divide. So if we look at this first example, x plus 6 equals 2. If your knowledge of integers is very good, you're going to be able to work that out in your head. But I want to show you the steps now so that we are going to develop. So we're going to develop techniques which will then allow us to work out more complex things like that, which aren't so easy to work out in your head. But we're going to start off by doing it with simple examples. So if you look at all of these, my therefore x equals 11, therefore x equals 7, you'll notice that my final conclusion is the variable equals a number, the variable equals a number. So I want to get the variable on its own on one side. So if I look at my left-hand side here, I've got an x and a 6 as my two terms, and there on the right-hand side I've simply got a constant 2. Now going back to here, you'll notice that we have the x, the variable, on one side, equals, and the number solution on the other side. So if I look at these three terms, the x is on the correct side. It's on the side where I want it to be. The 6 is not on the correct side because the constant needs to be on the right-hand side. So that's going to be my starting point. I'm going to write down what I've got. And then because the 6 is the number that I don't want to have in that position, if I take it away, it was added, the inverse operation of addition is subtracted. So if I take it away, 6 minus 6 is going to leave me with 0 here, which means I'll just be left with the x. And so I actually orchestrate what I want to do to that left-hand side to make sure that this constant number disappears. I then write down what I've got on the right-hand side already, and then maths is fair, so whatever you've done to the left-hand side, you have to do the same to the right-hand side. And I'm color-coding it at the moment to accentuate exactly what I'm doing. I'm doing something on the left and something on the right. So x plus 6 minus 6, that comes out to be 0, so I'm just left with x on this side, and 2 minus 6 is going to take me into the negatives and give me an answer of negative 4. And if I were to substitute that back now into the place of x, negative 4 plus 6 would give me 2, and the right-hand side is 2. So the beauty of these is by substituting your answer back into the variable, you can actually check ahead of time whether you've got the right answer or not. Let's look at 9 plus x is equal to negative 1. So even though the x is written second and the constant is written first, it doesn't matter. You simply need to look at the three terms and decide which ones are on the correct side and which ones are on the incorrect side. Well, 9 is a constant, so it should be on that side. So I'm trying to get it away from this side. X is in the correct place. Negative 1 is a constant, so it's also in the correct place. So this step here where I'm writing in my additive inverse, you're going to start leaving out, and you're going to use a shorthand very soon. But for now, let's just consolidate what this is all about. If this is 9, remember, if a number doesn't have a sign in front of it, it's automatically positive. So that means positive 9, so the inverse operation will be minus 9. What did I have on the right-hand side? I had negative 1. What did I do to the left-hand side? I need to do the same to the right-hand side. So this is the tidying up step now. 9 minus 9 is 0, so the numbers are disappearing, and I'm left with x. And negative 1 minus 9 is going to give me negative 10. Let's have a look at one last example. x minus 7 equals 5. So by now you should be able to spot very quickly which things are on the correct side and which things are on the incorrect side. So, but always I start by writing down my left-hand side as it is. And now I see I've got a negative 7. What's the inverse of negative 7? It's plus 7. So it's always exactly the same constant number, except whatever that sign is, you're going to do the additive inverse so that they come out to be equal to 0. Write down what you've already got, and then what did I do to the left? I added 7, do the same thing. So negative 7 plus 7 is 0. I'm left with x is equal to 5 plus 7 is 12. And if we sub that 12 back in there, 12 minus 7 definitely does give us 5. So in the next episode, we're going to be doing a few more examples like this, but we're going to be taking a shortcut, leaving out the red parts. And that will just make the whole process a lot easier. But as I've said, my first episode in any series is going into a lot of detail about exactly what the topic involves. So now you'll be able to recognize if something is a linear equation because the x's are all to the power of 1, and you've now learnt the technique of using the additive inverse to find the solution for x.